Hi, welcome to this lesson on Euclidean geometry, the proportionality theorem. Let's have a look at question 3. So in the diagram, we have this triangle, right, the larger triangle IJK, and a parallel line LM to the base JK. So we can essentially use the proportionality theorem here, because we have parallel lines in a triangle. Now we're given some information. JL is 2 units, LI is Y units, IM is 7 units, and MK is Y minus 2 units. They tell us that if these two lines LM and JK are parallel, calculate the value of Y to 2 decimal places. So I can say by the proportionality theorem, so by the prop theorem, we have, I can take the ratio of IM to MK will be the same as IL to LJ. So I can say IM divided by MK equals IL or LI over JL. So what was IM? It was 7. MK was Y minus 2. And equal to LI, which is Y over JL, which is 2. So now I need to solve for Y here. Okay, so what I can do is I can cross multiply both sides by 2 and then by Y minus 2. So 7 times 2 is going to be 14, and Y times Y minus 2. Okay, I can distribute the Y into the bracket, so I get 14 equals Y squared minus 2Y. And then I can bring over that 14, so I get Y squared minus 2Y minus 14 equals 0. So now I've reduced this geometrical problem using the proportionality theorem to an algebraic problem, which now uses a quadratic equation set equal to 0. So let's see if we can try and solve this. So I think we can try and factorize that. Factors of 14, that'll give you a difference of 2, while there's 1 and 14 and 2 and 7. All right. So which of those factors is going to give us a difference of 2? Okay, so if you look at that, you can see that it's most likely not going to be factorizable now that we look at it, right? Because none of those factors are going to give you a difference of 2. So I'll use the quadratic formula here. So y equals, my a value is 1 here, my b value is negative 2, and my c value is negative 14. So it's going to be negative b plus or minus, so 2 possible solutions. Square root of the discriminant term, b squared over 4 minus 4ac, all over 2a. So it's a negative 2, which is positive 2, plus or minus the square root of negative 2 squared, minus 4 times 1 times negative 14, all over 2 times 1. Okay, so it's going to be 2 plus or minus the square root of, so let's do that on our calculators. So negative 2 squared is 4, and then the minus becomes plus, so it's 4 times 14 there, so I get 60. Okay, so therefore there are 2 possible solutions. Y equals 2 plus the root of 60 over 2, or y equals 2 minus the root of 60 over 2. So notice that if I took a look at this first one, 2 minus the root of 60 over 2, I get negative 2.87. But that doesn't make sense. Y is a length, right? So y can't be a negative value. So this is not applicable in this context. So it must be the positive root solution here. And if I do that, I get 4.87 to 2 decimal places. 4.87 units. Okay, so I'll just put the word units there just to clarify that it's the units that we're dealing with. All right, so to recap with this one, we saw that there were 2 lines parallel in a triangle, so we could use the proportionality theorem. We took the relevant proportions and did our algebraic manipulation to get a quadratic equation set equals to 0. We thought it could be factorized, but after looking at the factors, we saw that it couldn't be factorized easily, so we proceeded to use the quadratic formula. All right, quadratic formula produces 2 solutions, but we have to just use a bit of logic here. This is a geometry problem. It doesn't make sense for lengths to be negative. Okay, so therefore we took the positive solution. Right, so this is how we would do this type of question. I'll see you in the next one.